Hi all, so welcome to the today's series. Today we will continue the AI main. So previously we have created the AI main who can just dance, but today we will add one more thing to it. So today our main AI which we have to target, he can search for different seat to sit together and he can sit and he can also dance. So this is our main AI. We have created the behavior tree for him. So this sit was empty. We have also created the actor class which was not pointed to any C++, so we will create that too. Let's go to the content, go to all C++, they see human actors. I will create one more and it will be the actor. Next I will name it as M seat. Create class. Okay, it is up. I will remove this folder and the I will be gone. So in seat, if we will see, there will be few components which we will add, and this one more thing I have to check if I have added the sit montages or not. So give me a second, let me check. Asset mesh, give me a second, it is not inside data. Maybe man demo animations, we are having the sit animations. Okay, next thing is we, okay, so first thing first, what we will do for these sit animations, we do have some offset, so already noted that. And what I will do, I will just select these all. So these are the four animation which we will use, although we I have added extra, so you can use that too. So for this four, I will just right click and I will create the montage, press save. So what seat will do, it will choose some random seat montages and will play them. Okay, so this is our first task. So let's start. Okay, let me close this quickly, and first I will add some components. For the seat montages I will use map, and which we can modify from the C++ itself. I always keep different set for the variables and the functions. So you property, add it anywhere. It will create a tmap. Tmap is the key value pairs. So here it will be unm montage. As soon as I'm pressing tab, it is including the header file for me for the montage. So make sure you are doing that too in case if it is not there. So tmap, and it will be dance montages. This is first, and okay. So to choose the random montage, I will create one function. And for every montage, I already said that there will be different offset. Like when we will make that character sit, he will have some offset from the seat. Sorry. So for that, what we will do, we will create one function which will write tuple. So t tuple, and in that tuple, we will write u and a montage and f vector. Let me explain you what's this if you don't know the tuple. Get random dance montage. What else do we need? Alt enter, generate definition. Okay. So what is tuple? Let's imagine you want to write something out in multiple. You want to return something from a function, but multiple variables. So this is one of the way. Another way you can use a struct, but struct is like you have to define it, then you can return it. But in tuple you can directly put this thing out and it is ready to write. So what we will do in here, I will return make tuple. So make tuple is the function which will make the tuple for you. Make tuple, and here we have to pass the parameters. So we will have those values here in the T map in dance montages. So what we will do, and what you can also do actually, it can okay, from the T map we have to get the keys first. So T array un montages dance montages available map dance montages, and I will get the dance montages map keys, get keys, will store those keys into dance montages. Once I have the key now, so I will get the unm montage selected montage is equals to dance montage map. Nope, no, sorry, dance montages. If here I will have to pass, you have to pass the index, so 0 comma dance montages dot num -1. Okay, so this is the range actually. So f math rend range, here you have to pass this. Okay, so here what we are doing, we are storing all the keys in dance montages, and from this random I will choose one random from 0 to whatever numbers we do have, and we will pass it. Okay, and in make tuple I will set the selected montage comma, here we have to get the offset. How we will get the offset? We have dance montages maps, and here I will pass the selected montage, and this is it, montage. Copy, save. Okay, I think we are ready with the dance montage and all, but we haven't created the components yet, so let's do that first. U property, add it anywhere. I don't think we need blueprint read write, but maybe in future, so I will give them blueprint read write, and category custom, I will say the same category for here for dance montage, so we can just directly save. And here we will create the uScene component. I'll root scene root component, control D. I will have one static mesh, use static mesh component, sm underscore seat, because we need that box to sit, or you can use just random seat. What else? I think these are the two things. And in the constructor, what we will do, first the scene root component is equals to the create default sub object use scene component text, we will name it same use scene component, and we will make this root scene root component. Okay, one of the error which we are getting because we haven't declared them as pointers, so let's do that. Now we will attach, we will make the copy, and we will store the static mesh for the seat also, static mesh for the seat. Actually I will attach it to the root component, so set up attachment to the scene root component. This is the seat. This is used static mesh component. Okay, this is good. What else do we need? Okay, so now the thing is AI will should able to interact with this m seat. So I will create one more function, like on interact, and it will be public. So, and in interact function I will call it from maybe from the behavior tree, so it will be in public and it will be blueprint callable. So your function blueprint callable void on interaction. I will pass the character, so a character AI we will name it just AI, it will be good. We will close this, alt enter, generate definition, and I will create one more variable in private actually. Okay, let me pass this function here, private. So inside the private I will declare the character, so if somebody is interacting I will save its reference, so interacted AI. Okay, so on interaction I will save the reference of that AI inside the interacted AI. Okay, so interacted AI is equals to the AI, and so how we will interact. So let's imagine some seat is there, so I will get the mesh component from that character and I will attach that mesh component to this actor with the proper offset. Then I will choose the random dance montage and I will play that. You got my point? So give me a second. So what will happen, so as let's imagine this guy, this is the main character, and I will create one seat. Let's imagine this is the seat. Okay, I will just use this as a seat. So as soon as I will go, I will go close to this box, he will try to sit over it. Okay, so how he will sit, we will detach it from the capsule itself and we will attach it to this actor. So this is our idea, so let's do that. Okay, so in the interaction part I will get the mesh, so use skeleton mesh component AI sk mesh is equals to interacted AI dot get mesh. As soon as okay, get mesh is the skeleton mesh. If it gives error, make sure that you are included the header file for the skeleton mesh component. Okay, so AI sk mesh dot attach to component, and we will use the root component of this class. So root component comma, and we will add attachment transform rule, attachment transform rules, keep relative transform. This is first. And second is I will get this get random montage is equals to get random montage. So we have stored it in the get random montage, my fault. In from the get random montage we will, okay, first we have to set the relative location for the AI mesh. So AI sk mesh dot set relative location, and we will set the relative location to nm get random montage. Okay, get random montage. Let's name it as get random montage. Random montage dot get, and it will be in the first place because at 0 we have the montage, at first we have the relative offset. Okay, we have set the location. Now we have to play the montage, and to play the montage we should have the reference of the static mesh, skeleton mesh. We already have that, and from the skeleton mesh we will have the response of anim instance. So u anim instance, ai anim instance is equals to aisk mesh dot get anim instance. Okay, it will be the pointer, my fault. And let's put it inside if this is valid, then ai anim instance dot montage play, and we will pass the random montage dot get 0. Now, so as soon as I have played my montage, I will wait till my animation is over. As soon as it is over, I will inform the behavior tree, okay, now I am done, so let me go. So how we will do that? I will bind it to the anim instance dot on montage ended. So this is already a delegate which we do have, add dynamic, and I will bind it to a function, and seat on montage finish ended, alt enter, create member, everything is fine, alt enter, generate definition. So on montage ended, what we will do, I will reattach that skeleton component back to the character itself. That is why we stored this. Okay, we haven't used it, right? So like interacted AI is still pending. Okay, so what we will do here, we will check if it is valid or not. If interacted AI is valid, then do this, and in the end we will put interacted AI to null pointer. Okay, so here what we'll do, we will again get the static mesh from the interacted AI. So AI sk mesh dot set relative location f vector. So we have like by default our AI at 0 0 minus 90, so I am putting that. You can put all the values which you have in the in your AI. So set relative rotation f rotator, we will 0 comma minus 90 comma 0. So if you will check inside any AI, if I will open my AI, this is the target one, AI main. So you can check we do have minus 90. It is somewhat minus 90, minus 87. I just put minus 90, I guess, and 0 0 minus 90. So I have put the same value here. So just to make everything at the same place, so I will put 0 0 minus 87, and now I'm done. Okay, so let's imagine now everything is good, but I'm not sending anything out to the behavior tree. So my idea is how we will send some data from this actor to the behavior tree. So because these things are independent, so my idea is to create, I will create one delegate. Delegate is something, okay, some event had happened, so you are sending some data to outside. Okay, if you have registered it, like, so this was one, so like this is one delegate. In, like, as soon as montage will end, this anim instance is binded. So as soon as this will end, so it will trigger this, it will broadcast a function like, okay, montage is ended, so whoever functions are binded to this function, they can call it out. So I will create the one custom delegate. So it, let's do that. So to declare a delegate, declare dynamic multicast, dynamic, declare dynamic multicast delegate. So there are different type of delegates. I don't want to pass any data, so I'm using the plain one. Okay, so and here, while declaring the name of the delegate, we have to prefix f. So on montage finish delegate, and we have to declare it, like, I do want to broadcast this delegate, so I have to declare it in my section also. So we will do that. So in public, the property, so you property blueprint assignable, and I will name it on montage finish delegate. Okay, so as soon as I am done, like, okay, the montage is ended, I will call this delegate on montage finish delegate dot broadcast. So as soon as, like, whoever whoever registered their function with this montage, they will receive this event. We will use this function in the behavior tree. So I think this part you have got, and we are all even. Now let's do one thing. I will create one task to make the character sit on the chair. So what I will do, open Explorer, I will go down to the AI brain. So random location, fine. Okay, I will copy one of them. Control C, Control V. I will name it as make AI sit. Make AI sit. Press OK. Okay. This one, let me change the key. So blackboard key, I do want the seat. So what we will do from the behavior tree, if you will go to the behavior tree, inside the blackboard we have created one BP seat object previously in my previous tutorial. So we already have it. We will pass this to this task. Okay, so we will name it as bbk seat. Everything is there. Okay, I have to change the name also. So find location will not be there, it will be make AI sit. Same will go here, or else it will go mbtt underscore make AI sit. Go to the CPP, let me copy this, go to CPP, let me remove this, copy paste it, select this, and the include this header file. Okay, I don't need anything, so I will delete everything out. I do want to get the value from the blackboard, so I will just remove everything out except this. Cross. Okay, so okay, get value as object, the blackboard key seat key name. Okay, so we are getting the value and we have to store it in the b a type, like mc type. So we will do that, uh, or we can just put auto just to make it simple. Auto a seat is equals to, okay, but we have to cast it also, cast to a seat. We have the seat, and I also want to have the reference for the AI. Auto AI is equals to owner component, sorry, owner comp dot get AI owner dot get pawn, and I will cast it to the to our AI. Cast a AI base. So what I will do, I will pass uh, this AI to seed dot on interaction, pass the AI. Okay, we need the character, so actually we can directly uh, we can just cast it to the character. We don't need to use the AI base. A character, and we'll pass the AI because it is also our type of character only. We need to include the definition of the character also. I will remove extra header files, and I will bind the function, so seat on montage finish delegate. So this is the delegate which we created. Add dynamic this comma, I will create one function here. So umbtt make AI sit on montage finish. Alt enter, create, alt enter, then a definition. Okay, perfect. So okay, so if you will look carefully, as soon as I will execute this task, make AI sit, it will consume some time because I am sitting there and my animation is playing. So I cannot pass or write anything, like here I cannot pass this result directly, like it's not a success or a bot. So we will put in progress, so it will tell behavior tree, okay, I am doing something which is consuming some time. And now as soon as I have binded, because I have binded this to this delegate, as soon as this delegate will be fired from the AI itself, I will get this here. And what I will do, finish latent task, and okay, so here I will finish the task, but here I should have the reference to the behavior tree itself, which we haven't stored. So what I will do, I will create the behavior tree component in private. I will create one variable, private u behavior tree component, behavior tree comp, behavior tree comp is equals to owner component. I have to pass the address, so we have it in the behavior comp. So bt comp comma the result, so ept node result succeeded. Okay. Okay, this is perfect. I think we are sorted here. Let's save everything out. And there is one more thing. Like we haven't created a task in which we will search for the seat. So let's do that also. It's already 30. Uh, okay, let's do that too. So or let's do one thing. We will do that in the next tutorial. So because it is already 30, we can quickly check if there is any. We will quickly check if we are getting some error or not. Control B. Okay, compile. We do have it. Okay, in AI seat there is some problem in include. In AI seat. Okay, it is inside MBT make sit. Uh, okay, we will put this here. And remove this. I think it should do the task. Compile. Okay, this one more error. It is in mc.h. mc.h. Okay, silly mistake. I forgot to put colon there. I think it should work now. Compile it again. Okay, it is working. It's successfully linked and passed. Now next thing is I do want to create the seat. So in actors BP seat I will reparent it. Open full class settings M seat. Select compile and save. In the viewport if you will check, we do have the scene root component and the SM seat. What I will do, I do want, okay, so what I want, I will use this the same crate. So let me go there, BP seat, will put it here. I think its size, if I will go to this, the size is 96. 80 saying 96. So what I will do, I will rotate it 180 degree and will shift 90. Ninety 96. Save. If I will place this now, this will work as seat now. So AI can sit somewhere, anywhere. We'll rotate it so its front side. Just check it. This is the world location. This is the local location. Now it is pointing to this direction, so they can sit. The AI can sit here. And in AI main also, we haven't created that make AI sit. This we can do, but for this AI seat object has to be valid. So this we will make it in the next tutorial. Thank you and have a nice day.